Good afternoon. Welcome to the webinar AutoCrear version 2.2. We'll have a 1-hour webinar about the news of this electrical clearance and creepage analysis tool. So I set up an agenda. First, I'd like to introduce the presenters, some information about GIA Informatik AG, and then Mr. Martinek will present news in version 2.2, and he will give also a preview of AutoCrear 3.0, which should be released in summer this year. Another information for you, if you're expecting, let's say, an overview presentation of AutoCrear, then we have to disappoint you, but we already set up a new webinar where you can also register for it, and in about a month we will have an overview presentation about the capabilities of AutoCrear version 2.2. So this webinar is more or less about news and preview for version 3.0. Who are the presenters? This is me, or similar. I'm a CAD simulation specialist at GIA Informatik, located in Switzerland. The guy in the middle, this is our salesperson, I think he's not in the call. And the most important person for this webinar is Dr. Inge Michael Martinek. He's the CEO of e-laborate. He invented AutoCrear, and he will give us brand new information about the new versions. GIA Informatik is a CAD reseller in the middle of Switzerland. We are partner of PTC and other interesting software companies in the CAD environment, and one of them is e-laborate, and so we are a reseller of e-laborate of AutoCrear. Okay, we're doing training and consulting with all that kind of software, and we have an own training center in the middle of Switzerland. That's all about, let's say, the information about GIA, about me, and so I would say I hand over to Michael, and we are looking forward to hear what's new in AutoCrear 2.2 and what's beyond 2.2, what's coming in 3.0. So it's all yours, Michael.
Thank you, Urs. Thank you for the introduction, and also thank you for hosting this webinar for us. I hope you can see my screen.
Perfect.
Yes. So my name is Michael Martinek. I'm the founder and the CEO of e-laborate Innovations, the developers of AutoCrear, and in this webinar it's meant for existing customers who are already using the software to give them an update about the new features in the version 2.2, so that you know what all the new buttons and features do. The version itself is just uploaded about an hour ago, so just in time for this webinar. So if you update your program, you should be in version 2.2. It's been quite a long time since the last release of 2.1. It's almost a year. Apologies for that. We spent the most of the time revising the entire geometric processing of the ODB++ data, which is quite a complex process. So we spent a lot of development time in the back end of the software. However, we also managed to do some new features in the front end, and these features I'd like to present in this webinar, also most of them in form of a live demo in the program. I also like to take this opportunity to give you a short preview of the upcoming version 3.0. We plan it to release this summer, and yeah, this will eventually release the whole ODB++ interface and the beta phase, and especially there's a big revision of the entire analysis tab. I hope the timings should be correct, 30 minutes for the new features, 10 minutes for the preview. Yeah, let's see. I haven't made yet a walkthrough. So let's start right away with the features. The first feature I would like to introduce is the concept of visibility states. A visibility state is, well, a state of hidden transparent components. So which of these are currently hidden or made transparent. These states you can now save in the session so that you can maybe you frequently need certain views on your assembly, then you can store them and reassign them anytime. So let me show you this in a, no, not in this one, in a live demo. So there is one default visibility state, must be one state active. So the default state just shows everything, so nothing is hidden. Now if I change the visibility, well, actually this better suits this process. So if I now change the visibility of certain parts, let's hide this one and this one, for example, make this transparent. For example, there's a nice view to the interior of certain parts, a view you might want to keep. Then you are able to, well, first of all, I changed the default state by hiding, and then this is indicated by the coloring of this pin. It was red before, now it's gray, and now I have the possibility to save the current state as a new state. I can call this, this is my nice view, and now the nice view is active. When I change this view by hiding some more things, the view is again with a gray color indicating that it's not active anymore, but I can anytime reapply this nice view. I can also, after changes have been made, for example, let's hide all the components of the top of this PCB. I could override my nice view state, or I can create a new state of this. For example, this is without the top components. Yeah, and by this you can store as many views as you like and restore them anytime. This is also very convenient in the end for the documentation, where you can reduce the documented parts to certain visibility states. And you might also miss the feature which hides the insulating parts here. This was a checkbox at this position, which was convenient for working on electric nets. And this is not vanished. It has just moved, because this actually perfectly fits into this concept of visibility states. It's part of it, and it's part of an automatic state. So beside the custom states, you can freely define for yourself. There are already some predefined automatic states, like for example, the show conductors state, which automatically hides all the insulators. There's also the opposite, show insulators, which makes the opposite. It's not totally the opposite, because there might be some components, like for example this one here, or the entire PCB components, which are not of one homogeneous material, and we can do the hide and show operations only on solid bodies. So if there is a solid body with different materials, with insulators and with conductive, they will appear in both visibility states. No, but this This is actually the mode which was the same as before with the checkbox, but now there are much more possibilities and the possibilities to define your own states. And also note that the automatic states cannot be deleted or overwritten. Only the custom states are freely editable. So then the next feature is removing of components or assemblies. It was quite uncomfortable if you have established an entire scene of different assemblies and PCBs. So you added more and more assemblies to your session, and at some point you mistakenly imported the wrong part, and there was no possibility to delete it again. So this is solved now. So so let me go back to state 1 of the workflow. It's only, you need to be in state 1 to remove things. As soon as you applied metadata, the geometry is frozen and you cannot delete anything. But so this is a choice you have to make on the first step of the workflow. You can delete individual components or parts. And if you do so, please note that they are permanently removed from the session, cannot be undone. They're also removed from this list, but you can also remove the entire assemblies. For example, you could go to the assembly selection where you can select the assembly as a whole. In the context menu, you find the remove. In the assembly operations here, you find the remove. Or you can right-click here on the list and can remove this assembly. If, for example, you have mistakenly added the wrong mechanical part here to this PCB, let's remove this. Also note that we cannot remove the individual layers of a PCB. So there's missing the remove function because the PCB can only be removed as a whole assembly, but not individual layers because they are already pre-processed in one single solid body, which cannot be separated anymore. If you don't want to have certain layers, you can already leave them out in the import mask of a PCB. The next thing is the advanced assembly positioning, which is also convenient if you want to combine multiple assemblies, especially electronical data and mechanical data. We can stay in this session for that. Let us just add a mechanical part here. This one, for example. And data which comes from these two worlds, ECAD and MCAD, is not aligned by default, usually. And now this brings you to the requirement that you need to position them correctly again. The previous versions, we had very simple handles for that. So you can select an assembly the one you want to move. You can edit the alignment here, and these are the known functions: the moving around with the handles, rotating, and so on. But using these simple methods for an exact positioning is not very helpful. It's only a rough approximation of the exact position. And for that, we introduced some snapping functions. What you also could do before is type in the exact translation vector here when you know what is the exact vector between this reference position here and the reference position in the moving object, then you could type in here, but I think this is rarely the case. For the exact positioning, we offer these functions here, where you can make properties for some certain geometric elements. For example, well, I want to make this edge here. If I'm in a mode, so the first thing I have to choose is which operation, whether I want to set something parallel, coincident, or distance. Let's set something parallel, and let's choose an edge of the item. So the item refers to the current assembly which we want to move. Now we could select an edge from this item. The anchor is the entire rest of the scene. The geometry which will stay fixed, so we only move the item somehow, so that the geometric property I just added here is assigned. And I want to be this edge here to be parallel to this edge. I confirm this, and now it's parallel. But note that this is not a constraint. It's just a snapping, a temporary snapping. I can still have all the degrees of freedom. Of course, we know that constraint-based modeling would be much more better, but this is way more complex. It will be in the software someday, but for the moment, I think it's sufficient for the snapping operations. Usually, you don't need many of them. For example, if you want to especially in the ECAD MCAD combinations, you might have drill holes which should coincide with the holes in the assembly. So I could select this cylinder here and want to make it coincident with the cylinder here. Then it will be automatically put together. Then, of course, you have to take care which operations you perform afterwards, not to spoil this this snapping. But now you could, for example, say, yeah, now I want that this this planar surface here on the bottom matches this one here, and by this you can also make exact positionings with these simple snapping functions. Maybe you already recognized them. We have released them silently before as a pre-release, but now they are officially released. They are also documented, and I refer to the manual for details. So the advanced positioning manual, as always, you find it in the help menu of the program. At the very first page, you find all of the features, the novel features, and you can directly jump to them. Here are details about these snapping operations. So what exactly happens if you snap an edge to another edge, and so on. In this case, for example, we would rotate around the midpoint of the item edge such that it's parallel to the anchor edge. And all the other informations are described here, what happens in details with the snapping. The next operation or the next feature is the possibility to set the default camera position. If you have, well, initially, if you import an assembly, there is a default position which is kind of random, and it might not always be the nicest view on the assembly. And let me go back to the slides for a short while. This default position is used in many occasions during the workflow. For example, for the automatic screenshot at the title page of the document, or for the automatic screenshots in the electric nets documentation, or for the assembly views of the paths, the automatic camera positions. For all of these camera screenshots, the default position is used. And if this default position is not very nice, well, then all of the automatic screenshots are bad. So that's why we offer the possibility that you can set a new default position. This is very simple. You just choose your position, like this one, for example, and then you find the option here in this tool, which was originally only contained by the reset and the align functions, but now you have here the function set default position. You just click it and now it's set to the current camera. So a reset operation will reset this default view, and also all of the screenshots which are based on this default position are made with this nicer view. The last option, the reset default position, is meant for resetting the original default, the originally computed view. And very close to this feature is the next feature. I want to introduce the recomputation of default camera positions for the paths. So now suppose you have an old session with lots of results, and every result contains assembly view with the old default position. Now we have the possibility to save the new, override this ugly default position by a better one, and you might want to update all of your results here without requiring a new computation. And for that, we introduced a function where you can recompute the camera positions of the paths. The path itself stays the same, the result is not touched, but this is a way to automatically compute new camera positions. And you can also choose an individual position for a certain net pair, for example. Well, if for example all of the paths in referring to this source would look the nicest way from this view here, and now you want to override all the default assembly views of these paths with this view, then you can make a recomputation. Now you choose the camera position. In this case, we want to use the current camera position. We can select for which path we should do the recomputation, like for example only for the current source and all of its targets. And you define the name of the camera position. By default it's the assembly view, because actually this is the basic application you want to do is to override the current default view assembly with the new computation. So this is done by just using the same name, and then the old ones will be overwritten, but you can also choose a new name, and then the old one are still there and the new one are added to the list of camera positions. But in this case we want to override them. We can also choose which path features should be active. For example, I want also highlight path active, and then I click on compute. And now for all the paths, the default assembly view is updated to the current path view. This is the assembly view, and that's a nice feature to update the paths or the camera positions at the post-process after computation.
Question here was, sorry, a question here was, can you reorder the views in the camera position window? Sorry.
You need an ordering here in this?
Yeah, I think so.
Yes, I also think so. No, there's no order, but if this is a requirement, no problem. We put it in our list. This is a very simple feature, so we can integrate this in one of the future and the subsequent versions. But at the moment, there's no sorting.
Okay, thank you.
We introduced some new features for exporting results. The biggest of them is the violation matrix, which looks like this. Let me also show it here in the program. So this is generally here the export button, and now there is a new function, export the violation matrix. And this creates an Excel sheet, the matrix, which indicates all the violations. So now Excel opens, and in this case it looks like this. I just exported the indication, so you see where are the violations, the strict violations in red, the minor violations in yellow, or the OK in green. So there you can see directly, okay, there are 3 violations in my assembly, one between main A and ground, and so on. It creates one table for clearance and another one for creepage. As you have seen, there are more options to this. You can also include the shortest path as a text, the violation distance. So if I open it with this option, then every item of the matrix not only has the indication of the violation, but also the distance of the shortest path, and also the distance which needs to be fulfilled. And that's a nice overview over all violations, rather than having to toggle through all of the sources here to see where the violations exactly are. Another new export function is the URF file for Zucken. This is also a beta version. We had a customer who used the system Zucken for eCAD, and Zucken provides an interface to see clearance and creepage paths in the program. And this interface, we are able to, or this file format, we're able to export from the current results, so that you can import the paths in Zucken. I suppose that other eCAD systems have the same capability, and if there is a need, a requirement for that, we can also extend this export functions to other systems. You just need an example, or even better would be specification of these files. Sorry, I don't have a screenshot of how it looks in Zucken because we don't have a Zucken license, but I think if you are dealing with eCAD data, you might as well know how this looks like. Oh, the copy to clipboard function is also new, I think. It's located in the path info of each path. So if I select a path, here in the information field is this icon here, which provides you just the coordinates of the respective polyline representing the path. And maybe you can import this directly into some system for visualization, and just by clicking on it, it's copied to the clipboard. Then you can paste it into another program which might be able to visualize the path in another environment. We introduced some advanced automatic merge functions. So the auto merge, just to remind you, is a function which merges nets which are very close to each other but not really connected. Initially, AutoCrear computes all the nets which by means of conductive elements which touch or intersect each other, but there might be some gaps like this one here, and this can be taken into account by introducing a threshold, like for example 0.1 millimeter, pushing AutoCrear nets, and then again a net merging is triggered where all the net pairs which are closer than the threshold value are also merged. This was for many applications which also include CAD data to one-dimensional, because gaps in the MCAD world might be so big that they could be actually really distances in the ECAD on the PCBs, which would also be merged maybe. So in this example, for example, the X is an unwanted gap. If I would make a complete auto merge over the entire assembly with this value, you might also get the nets B and C or C and D merged, and that's of course an undesired effect. And therefore, we revise the auto merge function by more features. We go back to the program. Here I have an example for this. This is actually the same example with the pins. I can, before I start this tool, I can select certain nets which I want to use as key elements for the net merging. For example, only the pins. And I go to auto merge, and now I can choose whether I want to merge only the current selection with possible nearest neighbors or all the nets. So if I choose all nets, and here also all nets with a threshold, this is the old function. But now, as I selected only the pins, I can say, no, I want only the current selection to be merged with other nets. So everything which is, let's say, 0.2 millimeter away from these pins should be merged. And I can also decide whether I want to merge all the nets which are within this distance away from each pin, or only the nearest neighbor. This can also be convenient because, well, you might not know how big the threshold should be not to merge the pins with other nets which should have a gap. But when you are sure that the nearest neighbor of each pin is its hole, then you can choose the nearest neighbor only, and then you're on the safe side. And another big advantage of this new auto merge function is that you get a feedback before it's eventually merged. You get a feedback window where every merged net pair, or maybe also consisting of multiple nets, more than two, is listed here with different colors. So each subsequent nets in the same color are merged together. It switches from black to blue. So these two nets are merged together. Then we have a section of blue. These two nets are merged together, and these two. So you can check again here if every merge process is correct. And if it's not, you can also deselect the respective nets to prevent it from being merged. And then confirming this will eventually lead to the effect of merging the nets. Some minor novelties we introduced are advanced visualization features. For example, the screenshots, the automatic screenshots in the electric nets documentation, where we take 2 screenshots of each net, one which shows the net separated and one which shows the net in the context of the entire assembly. For bigger assemblies, and especially if the nets are located deep in the interior, this was kind of a worthless view. You could not really see where the net is. This is the old version. You see in the new version we introduced some much more elaborate methods for highlighting nets even if they are in the interior. There is also a nice ring around them so that you can always see where the net is, no matter how small it is or how thin. Some minor revision is this highlight path feature, which was originally just a bounding box which we filled with red. Now it's a screen aligned circle around the highlighted path. So this is the highlight path feature you already know from the result display. Another minor novelty is that we automatically store and restore a session after a crash. This might be very inconvenient for you if you have put in all your material values for big assemblies and then you push apply metadata and the program crashes due to some geometric error, and you haven't saved the session before. This is bad. You have to start all over again, typing your material values again. Now you don't have to. We automatically store the sessions before crucial steps are made, and if they crash, then in the next program start you get a message and the possibility to restore the session again. Well, of course, performing the same operation again will most certainly crash again. But you can immediately use the session to give us a bug report. We fix it in a short time, get it back, and you can continue your work on the assembly. Other minor novelties include some new options in the documentation creator. For example, the part list, which automatically generates a list of all the parts in the assembly in the document, can be reduced. So by default, all the parts in the assembly are documented and appear in the list, but maybe you have some data which is consists of many tiny parts, like the components on a PCB, for example, and you don't want them to appear in your document because they would increase the page size by maybe 100, depending on the size of a PCB. And for that, you can reduce the parts to be documented by options in the documentation creating tool. So there is a selection of parts. You can deselect parts manually. You can also make a, for example, automatic deselection of conductive parts if you only want to document the insulators, as the material of the others is anyway clear. Or the easiest way is probably to select a current or some of your visibility states. So you could establish a visibility state where all the tiny parts are hidden, and then you can just select the visibility state here, and the document will only contain the visible parts in the visibility state. We have some advanced options for net groups in the documentation for electric nets. I refer to the manual for details. And then there is also a revision of the analysis summary in the document. The analysis summary lists all the net pairs and tells you the worst result. And now it also displays the path, the shortest path lengths, and distances which are required. And a major improvement we made in this version is more or less invisible. It's an improvement in the back end. So the entire process of generating the 3D model out of the two-dimensional ODB++ data is completely revised. It's much more robust now. We had to learn a lot about CAD data in the last 12 months, and we put this knowledge now into the new version, and this should be fine now. It's not only more robust, it's more efficient. The net detection is more exact. You can also now work with a special types, layer types like solder masks, solder pass screens. And also the computation is massively affected by this improvement because we store adjacency information between layers, and this makes the clearance and creepage computation on the PCB much faster than before. You might also recognize some minor improvements in the front end. So, for example, the dielectrics are fixed in this structure here, and in between them you find the signals which you can deselect or select. Yeah, this is an improvement which is already in the version 2.2, but what is still to do for the final release of the ODB++ interface is the next step, where you efficiently want to specify and manage the requirements for the analysis. We have a combined assembly here, and you have certain requirements for your mechanics which might come from standard tables. Then you have different requirements for your PCB. They can come from certain in files, exchange files. In Sucon, it's, for example, the MTX file. You might have different requirements for certain areas in your assembly. For example, if they have a different pollution degree. You might have different requirements for the path between the mechanical and the ECAD components. Yeah, and this is to be included into the parameters for the analysis, so we can cover all of these aspects in one configuration, in one analysis. And that's something which is hard because we don't want to overload the program with unnecessary stuff, so we need to find a good solution here. And this is also my transfer to the last topic, introducing or previewing the version 3.0, which exactly does this. It solves, or it should solve, the problem we have here, that we have many different requirements and we have to combine them somehow into a single configuration. And also another problem is that each of these configurations or the requirements also include different paths, different length for geometric properties. For example, for PCBs, you have a different distance requirement for the external layers than for the internal layers. So between one and the same net pairs, you have different requirements depending on the geometry. And this is also something which is not possible in the current version. We only can introduce, or this is the status quo. We have one value for clearance which we can type in for each pair of nets. We have one clearance value. Well, and this is all. So you would have to perform one analysis for the external rules, typing them here, one for the internal. But this is, of course, not very convenient. And it's also not possible to define different areas which might have different requirements. So this configuration methods are way too one-dimensional for our new requirements. And therefore, we introduce a major revision of the entire analysis tab. So this will get a complete new look in the version 3.0. And there is a clear distinction now between requirements and configuration. The requirements are, for example, your standard tables, your ECAD rules, which come from these exchange files from the ECAD system. The standard tables might come from the standard table as an Excel sheet, or you can define custom rules. For example, your personal 800 volt rule, which you fill with values for all CTI values, for example. And defining such requirements is not yet configuration. It's just you define your tools for the next step, where you assign each net pair a configuration. And most of them also happen automatically, because we know what a PCB, what an PCB is due to the ODB++ import, and we know which file belongs to that, so we can automatically fill the section where only the net pairs between the net groups of the PCB are located. So they are assigned the ECAD rule. The rest is assigned the standard table, and there are some other which are assigned the custom rules. So this actually looks like this in the live program. So you can define your requirements, and then you can freely select in the matrix directly the net pairs, telling it, oh, for this net pair, this requirement should be applied, and so on. You also can define multiple regions in your assembly, and then assign different requirements for different regions within a configuration. For example, you have a region which has a different pollution degree, then you need another standard table. This you can do by switching the region, assigning different stuff here. And this is also if you have only mechanical parts and or assemblies, and you standard table would be a total overkill for you, because you only have 3 different voltage differences appearing in your assemblies, reflecting to 3 different requirements. You just can define certain of these requirements with custom values, defining them, one rule for 800 volt difference, one for 400, and so on. And then you have these requirements as building blocks in your matrix view, and can assign them. Of course, you can assign a color so that you can really nicely see which requirement is applied to which net pair. And that's our idea, to combine all these worlds to a single configuration. And there's also a wizard which assists you to initialize these requirements. For example, it recognizes that a PCB is located in your assembly, and it asks if you might have, if you have a configuration file from your ECAD system. It asks you whether you want to consider CTI values so that it can tailor-make the user interface for your requirements, so that it's not overloaded with stuff you don't need. And there's also, of course, a legacy support. If you have older sessions, the legacy is just a requirement, one requirement of type custom table. So it's also, you can also define such a requirement where you can fill the entire table distance matrix just as you do in the current version, and this is applied to all net pairs. So this is the legacy support of the new feature. Yeah, this will be released in the summer, I hope. The ECAD, and by the release of the versions 3.0, the entire ECAD interface, the ODB++ interface, changes from beta to the release status, but we will still leave the program for free in AutoCrear, at least until end of this year, so that all of you can test the new configurations, the new data import of the ODB files, and maybe we find some problems which we can fix in this year. So that was all from my side.
Great. Thanks a lot for your very, very interesting information. Now, as you can see on Michael's presentation, we are in the Q&A session. So far, we do not have that many questions. Just one customer stated that, let's say, the definition of a new initial view which you can use in the documentation is very worthwhile for him. He likes it very much. So my statement to all the attendees: are there more questions? Please type them in the question panel. Michael tries to answer them. If you have later on some questions, send us an email. Here you can see the email addresses of all of us. So I think we wait maybe another minute or so. In the meanwhile, maybe you can show the next slide, Michael, with the webinar, let's say the overview webinar, that everybody's aware that we also plan at the end of May an additional webinar where we show, let's say, an overview, the whole process of clearance and creepage analysis with version 2.2 that will take place, I think it's May 28th. Same time as today. We will send out emails to you where you can also register for this webinar, but just for information, about 1 month this webinar will take place.
Yes.
Now questions are coming in. Can you see them, Michael? Do you have access to the question panel?
No, I'm depending on your statements. Yeah, so the overview presentation on next month is probably boring for active customers who already know the software, because it's addressing the basic features. But maybe you have other divisions in your company which might also be interested in AutoCrear. Who want to see the entire workflow of AutoCrear. Then you are free to provide this information to your colleagues.
Well, one customer is stating, I had exactly 4 open questions and they got solved with the new feature. Thank you. Very nice statement. Wait.
That's good to hear. And if you have further ideas or requirements for new features, please feel free to use this feedback function in the program. We also are happy for each positive feedback. If you so that we also know which of the features are very popular with our customers. Or if you have suggestions for new features, use this button here and we will put this into our list and introduce them in one of the future versions.
So just a hint from a customer, maybe for next presentation, we should use, let's say, a bigger cursor, because they cannot see, let's say, where you point in the program exactly. So maybe I show you then zoom it, or you might use later on, let's say, a bigger cursor of your mouse, that all of us can see where clearly where you point to.
Yeah, that's a good point. I will take this into account.
Thanks a lot for this information.
Yeah, thank you.
But then I would say, I think we are at the end of the webinar. And I really would like to thank Michael for this new release and presentation of the news for this exciting future we're going to have with, I would say, with AutoCrear version 3. And I think even now we can do quite a lot, and I think it's very important that we really test a new feature, and if we have any topics we like or we dislike, give feedback to e-laborate. They are really open-minded, and they like to let's say have successful customers, and yes, they are doing everything for you, or nearly everything for you. So yeah, from my side, thanks a lot.
Yeah, it's still our only product we have on the market. We concentrate only on this topic, clearance and creepage, and want to develop a software and establish it on the market which solves, or which is applicable on almost every possible application for clearance and creepage issues. And so from my side also, thank you for watching this webinar. Hope to see you soon in the next webinar for about version 3.0 this summer. And good luck with working on the software, and give us feedback whenever you have problems.
Thanks from my side, and maybe Michael, you can switch the next 2 slides. Then we come to the end, and here is let's say the link for the overview presentation, and the last slide is just to thank you for your time. I hope it was interesting, and yes, keep safe and sound, stay at home, and we hope to meet you in the future, not only online. We'd like to see also live somewhere at your company or somewhere else. Thanks a lot, and